here. There's 24 out of 160. 24 out of 160. They do 6 hours and 30,000 euros, gives us 48 chances out of 160. And finally, they do 6 hours and 35,000 euros, just 28 of them. Okay, gives us 28 out of 160. And then finally, we have in relation to the 9-hour branch that could be associated with 25,000 euros, 30,000 euros, and 35,000 euros, giving us the probability that x is equal to 9 and x is equal to 25, the probability that x is equal to 9 and x is equal to 30, and this branch here would be the probability that x is equal to 9 and x is equal to 35, okay, which gives us, okay, in this case, we have x is 9 and 25. Well, let's have a look. When x is 9 and 25, there's 6 people out of 160. Okay? When x is 9 and 30,000 euros, there's 12 people out of 160. And when x is 9 and 35, there's 25. There's 20 people out of 160, giving us all of these joint events. Okay? So all of the joint events here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them, which correspond to the 9 individual values within the table, because they represent two characteristics, yeah, a measurement on both variables, if that makes sense. Okay, so here's our marginal probabilities. Okay, there are marginal probabilities, and our joint probabilities are all of these things, are all of these probabilities down this particular column here. Okay, or down the leaves of the probability tree. Now we might ask ourselves the question, okay, so now that we know the marginal probabilities and we know the joint probabilities, can we calculate the conditional probabilities? Which we can do, and there's a simple formula for that. Okay, the formula says something like this. Okay, well, let's have a look at the multiplication rule, the multiplication rule. Okay, and the multiplication rule says this, is that the probability of A and B is equal to the probability of A times the probability of B, knowing that A has occurred, when they're dependent on each other. Okay? And if they're not dependent, and if they're independent, it just simply boils down to the probability of A times the probability of B, okay, when they're independent. Okay? The point being that if we calculate this thing here and it turns out to be the same as this, well, then we know they're independent. Yeah, okay. So let's just use this here as our particular rule. So now what we have is this, because these are the conditional probabilities. Yeah, okay. So now we have from this guy here, okay. So from this rule here, which relates the joint probability to the marginal probabilities and the conditional probabilities. So now we have from the probability of A and B being equal to the probability of A times the probability of B knowing A. Okay? Well, what we now have through algebra is that the probability of B knowing A is equal to the probability of A and B divided by the probability of A. Okay? So what it says that if you want to calculate the joint event of B knowing A, well, then what you do is you calculate if you want to calculate the conditional event of B knowing A, well, then you calculate the joint event and divide by its marginal probability. Okay? This thing is what happened first, or the margin. This is the marginal here. Okay? If that makes sense. And this is the joint. That's the joint event. Okay? So if we're interested in knowing what's the probability, okay? Now, the way this tree is laid out here, okay, this tree is laid out that the conditional, okay, or let's say the information that's provided, yeah, in this case is work experience, yeah, okay, which was always going to be this marginal here. So knowing one of these things, can we figure out what these probabilities would be down here of getting 25, 30 or 35,000 euros? So for example, let's say I want to calculate what's the probability that the person selected is on 30,000 euros, knowing that the person selected was on 6 hours of work. Okay, if I want to calculate this probability here, okay, well, let's have a look where that is on the tree. So we know that they're on 6 hours. So the person I'm looking for is down this branch here. So I know they're down this branch, yeah, and I want to know what's the probability that they're earning 30,000 euros. Well, let's call this B. and let's call this A. Okay, so that looks like this here. So this is going to be the same as the probability that the person is on 6 hours and they're on 30,000 euros divided by the probability of A, which is the probability that the person is on 6 hours work. Okay. Now from our from our tree, we know that the probability that the person is on 6 hours and 30,000 euros, 6 hours and 30,000 euros is 45 over 160. So you have 45 chances over 160 for this piece here, which needs to be divided by the probability that they're on 6 hours, which is a marginal probability. The probability that they're on 6 hours is 100 over 160. So that's 100 over 160, which gives us 45 over 160. Invert and multiply times 160 over 100, which now gives us, in this case, they cancel, gives us 45 chances out of 100, which is what we'd expect from our table. The probability that the person's on 30,000 euros knowing that they do 6 hours, well, there you go. Knowing that they do 6 hours means that they're in here and there is 100 of them. What's the probability that they're on 30,000 euros? Well, there's 48 people out of the 100. Gives us the fractional amount that we calculated here through using the multiplication rule and the conditional probability version of the multiplication rule. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this short video, I hope that it was in some way intuitive, and more importantly, I hope that was helpful for you, and thank you for watching. Okay, bye bye.